Yeah, Pradala, this is the first episode of Inorganic Chemistry, Unit 6, Chemistry of SPD block elements. So then I will be introducing the inorganic chemistry part here, and we'll be starting S block, and we'll be discussing more topics related to S block. Okay, so this is the introductory session. I mean the first session. Okay. You know the time period for this lesson. This is like 64 periods. So 64 periods means nearly this 2.5 months or like 3 months. So then we'll be discussing this lesson for 3 months. Okay, starting from this July, August, September. We'll be finishing this lesson by September, or it depends on the conditions that we will be facing in upcoming future, right? Okay. Other topic in your notebook, Unit 6. Okay. This section is inorganic chemistry, right? We have finished physical part and we have moved to the inorganic chemistry. This is Unit 6, chemistry of SPD block elements. Chemistry of S simple, P, and D block elements. Chemistry of SPD block elements. And then write the content. Chemistry of SPD block elements and write the content. Right. So then before writing the content here, content is simple here. Before writing the content, let's get the area around us, right? Number 1. Okay. Do not write anything, just say it. Now, first of all, I will show. This was the marking sheet now. Right. This is your resource book. For inorganic chemistry, there's a separate resource book. You have to refer it. So do we have to get a printout? There are 64 pages. 64 pages. Do we have to get a printout? Yes. It's better to get a printout of inorganic resource book, right? I mean, if you have to print out extra, right? I mean, it is optional, but for inorganic chemistry, it is very important to get a printout, right? Because the questions that they are asking, they're directly asking from 2 books. Number 1 from resource book. Number 2 is from practical guide. So then do not refer any other books than this. Right? Our note is just like a short note, right? And then resource book, and then the practical guide. Right? So then if you want to refer some industrial books, there are many more books. Right? JDL, there's advanced inorganic chemistry. There are many more books, but referring those books will not give the syllabus. I mean, what are the things available inside the syllabus? Just think. Now, in the question paper, they are telling there's a blue color precipitate. E is a blue color precipitate. So in this chemistry world, there can be 20 to 30 blue color precipitates. But in our syllabus, there's like 2 or 3 blue color precipitates. Right? Okay, syllabus blue color precipitates and amount. Green color precipitates, like 3 green color precipitates: ferrous hydroxide, nickel hydroxide, and chromic hydroxide. Is it clear? That's what I am telling. Please do not refer any other books. When I refer karanne resource book, our note, practical guide. Okay. So this is our resource book, chemistry of SPD block elements. So then you can see that we have to start from here, S block elements. Right. Let's see what is S block elements, and then here P block elements. Right. So then after finishing P block elements, we have to discuss the D block elements. Right. D block elements. Then that's all. Right. I mean, this is not a perfect resource book, because with this part, you should know about cation test and anion test. Why I am saying like that? Because in the last day session also I explained that. So I can just show the 2021 paper. Right, 2021 paper there under the paper discussions. Right. So then you can see 2021 A-level paper. This is 2021 A-level paper, and then this is question number 7, question number 9. Right, question number 9. So then this is the following questions based on qualitative analysis of cations. Right, this is 2021 A-level paper. So in aqueous solution, Q contains 4 cations and for A, B, C, D subjected to the reaction. So then actually, when you amplify this is cation analysis, or this is group analysis, right? This part is group analysis. So when we consider this group analysis case, okay, unfortunately, this question is available in your ionic equilibrium lesson. Again, මේ question එකට theory එක තියෙන්නේ ඔයගොල්ලෝගේ ionic equilibrium lesson. Unit 12 case B or ionic equilibrium. So then we can't do like that. Definitely, I'll be taking that part from ionic equilibrium and explaining you with this lesson. So then when you are learning in school also, definitely you have to do like that. Otherwise, it's a big trouble because inorganic chemistry is a section to study, not to calculate. But ionic equilibrium is a section to calculate. There are many more calculations. It's a physical chemistry lesson. Then how to keep the inorganic chemistry parts in ionic equilibrium? There's a connection. There's a big connection between the two lessons. But we have to separate this and study, and we have to do questions. So then we can't do 2021 A-level question if you are just learning D block according to the resource book. There are 2 other topics you have to know: cation test and anion test. Right? Cation test and anion test. So then I'm moving to the resource book now. Right? I'm going to move to the resource book. So then this is your resource book. Sorry, not the resource book, practicals guide. This is practicals guide. So what is the importance of the practical guide? Right? You know from inorganic how many practicals that they are asked. Right? So then experiment number, let's see, experiment number 6. Right? Experiment number 6, this one. Not experiment number 6, this one, right? Experiment number 9. From experiment number 9, how many practicals do you think? Right? Practicals here, okay. Experiment number 9 to experiment number 23, these are inorganic practicals. How many practicals? Right? 1, 2. Yeah. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? There are 15 practicals. 15 practicals you should practice under inorganic chemistry. Right? Under this inorganic chemistry part, there's 15 practicals we have to focus. Yeah. Okay, so then that is the important thing. So there are 15 practicals. Practicals 15ක් තියෙනවා මේකේ focus කරගන්න. So then how we discuss this section? We'll be discussing the theory note according to the resource book, and we'll be writing a complete note. Right? We don't give a printed material and ask you to fill the blanks or any other printed notes. Definitely the note is written, but it's a very compacted note and it's a short note. With that, we'll be discussing questions. Right? We'll be discussing questions with that compacted note, more and more questions. So in this lesson, there are no calculations. කිසිම calculation එකක් නැහැ. There's no equation. You have to study. මොනවද කියන්නේ මොනවද study කරන්න ඕනේ. Right? So in your O levels, try to remember magnesium. What are the products will you get when you react magnesium with cool water? What are the products will you get when you react magnesium with cool water? Any answers? Then if you know the answer, or if you don't know the answer, that means that is inorganic, right? You have to revise. You have to recall. Then you have to give something. That's inorganic. ඒක තමයි inorganic. දන්නවනම් උත්තරය කියන්න පුළුවන්, දන්නේ නැත්නම් බෑ. So that is very important to keep trends in your mind in this lesson. මේ lesson එකේදී trends මතක තියාගන්න. Right? Magnesium with cool water. I'm asking the products, but unfortunately, magnesium doesn't react with cold water. But if you heat that solution, if you warm that solution, magnesium reacts with warm water or hot water to form magnesium hydroxide plus H2. Right? So then how to keep remember these products? Do we have to by heart equations? No. You have to by heart trends. Trends තමයි by heart trending. Under one trend, there's like 10 equations. 5 equations. We don't want to by heart each and every equation. We have to by heart trends. I'll explain what is a trend and what are the equations in the today's session. So this is the introductory session, in the first session. So get the idea really well. Okay, what are the questions that they are asking from inorganic chemistry? These are the questions they are asking from inorganic chemistry. I can show you other questions from 2021 paper. I think last day I have shown it. I'm not going to explain it in detail, right? So you know, question 9, right? And the method question number here question number 9A is inorganic chemistry, right? So 9A එකත් එක්ක අහන අනිත් question එක මොකද්ද? 9A එකත් එක්ක අහන 9B එක redox, right? So this is third lesson. දැන් මේක තමයි අපි paper class එකේදී එහෙම revise කරන්න ගන්න මේ lesson එකේ revision එකක් හරි. අපි weeks 3ක් විතර කරන්නේ redox, right? And then here HRI inorganic වල තියෙන 9 එක. Then after that මෙතන තව question එකක් තියෙනවා පුතා. question number 7 එක. හරි. හරි question number 7 එකේ මේ part එක කියලා බලන්න. The following questions are based on the element manganese. Write the complete electronic configuration of manganese. Cream common oxidation status of manganese. State the color of solution P. IUPAC name of the species. Can you understand? So the essay paper එකේ questions දෙකක් අහනවා. එකක් තමයි 7B අනිත් එක 9B. දෙකම inorganic. right. අපි section එකක් පටන් ගන්න කලින් එකෙන් අහන questions ටික මොනවද කියලා ඉන්න. right. මොකද මේ section එක උගන්වන්නේ ඔයගොල්ලන්ට ඒ questions ටික කරගන්න පුළුවන් වෙන්නේ. වෙන මොකකටවත් නෙමෙයි. දැන් මම කිව්වා practicals 15ක් තියෙනවා. S block, P block, D block, pattern test, and test. So then in the essay paper you get 2 half questions, 9A and 7B. In the structured essay paper, what is the inorganic question? Question number, first question is from general chemistry. Third question is from physical chemistry. Fourth question is from organic chemistry. Definitely, question number 2 is from inorganic chemistry, right? So let's focus question number 2 here. Under the inorganic chemistry part, you can see the question here. This is inorganic question, right? Panikam product here. B is an anion containing only 2 elements X and Y in the ratio of 2 to 3 respectively. Both X and Y are P block elements that belongs to the same group. That belongs to the same group in the period table. The atomic number of each element is less than 20. Electronegativity of X is less than electronegativity of Y. I mean, this is the typical inorganic question. They won't give the element. Element like manganese, right? The configuration. No. In the structured essay question, they will be giving hints. They will be giving some sentence-wise statements related to an unknown element. You have to identify. That means that will arise and that will make you to think around the topic, around each and every section. So then you have to have a good connectivity about this, right? The inorganic can වෙනම එකක් bio කරනාට මේක ටිකක් ලේසි වෙන්න පුළුවන්. මොකද bio වගේම තමයි මේක කියන්නේ. පාඩම් කරලා හරි හිතුවා ලිව්වා. එහෙම සීන් එකක් තියෙනවා, right? But maths කරනාටත් මේක ලේසි වෙනවා එක විදිහකට. මොකද maths කරනාට equations පාඩම් කරනවා. trigonometry වල equations තියෙනවා, right? ඒක sections වල තියෙනවනේ මතක තියාගන්න ඕනේ. ඒ වගේ තමයි මේකෙත් ඇත්තටම පුතාලා මතක තියාගන්න equations නෙවෙයි trends. ඒ වගේම colors ටිකක් තියෙනවා. At the end, you have to study some colors, like tetramine, copper 2 ion is blue color. Because we are doing some practicals and we are giving some practical videos. In your school also, you will be doing practicals. So then you have to remember those things, right? So we will make this interesting. No need to worry about that. From after each and every session, you have to study them. හැම session එකක්ම ඉවර වෙනකොට එදා කරපු ටික පාඩම් කරන්න ඕන අනිත් දවසට. Because in my next session I will ask questions, memory plus questions, right? I mean, what are the questions that I will be asking in the next session? You have to practice in the at home, right? One questions අහනවා විනාඩි 10ක්. ඒතර බලමු මේවට කවුද answers දෙන්නේ කියලා. ඒතර අනිත් අයත් ඒ questions වලට answers දෙන විදිහට පාඩම් කරලා ලෑස්ති. right? දැන් මම පොඩි question එකක් ආවේ orders වල. What are the products when you get when magnesium reacts with pool? But you should know that magnesium doesn't react with pool. That's why. So in inorganic chemistry, memorizing, keeping in your mind, okay, memory is really important. Okay. So then this is that structured essay question. And then you will be getting 5 MCQs. MCQs පහක් විතරක් දෙන්න. Okay. We're going to write. Write this. Content number 1. S block elements. S block elements. This is the content page, right? Number 2. P block elements. Hey, S එක capital the simple the simple. S කියන්නේ sharp කියන idea එක. Right? Simple S ලියන්න. P block elements. Number 2, p block elements. Right. The number 3, it is d block elements. S block elements, p block elements, and d block elements. The number 4, mention cation test. Test for cations. Test for cations. Test for cations. This is also known as qualitative analysis. Qualitative analysis. Test for cations, or it is called qualitative analysis. And number 5, test for anions. Test for anions. Test for cations and test for anions. Right? Is that all? Yes, but after this you should write practicals. Right? So I can pass it down on practicals. What about the internet? I can say my side again. Organize book and side again. Did you know? Didn't liyan. With practicals, pahalawak liyan na tuh. Right? Practicals paha period shorten kala liyamu. Short form again liyamu. Right? Practicals. So under practicals, we are going to categorize. We are going to analyze the practicals for these sections, right? නැත්නම් මෙහෙම කරන්නත් පුළුවන් ඔව් මේ sections වලට practical නම් දෙක ලියමු නේද? practical එකේ name එකම ලියන්න ඕනෙත් නැහැ. හරි. මට practical එකේ name එක ලියමු. දැන් මතක හිටිනවනේ නේ. මොකද ඔකට වෙලාව ගියාට පොඩ්ඩක්. So then මේක ඉවරයිනේ. S block, P block, D block, test for cations, qualitative analysis, and test for anions. Clear? So there is content, theory content. Theory content. So I'll be starting S block elements today. If I'm giving the relative time, S block elements වලට මට දවස් 3ක් විතර යයි. class දවස්. P block elements nearly 3 days. Right? D block elements nearly 2 days. Can be 3 days also. Test for cation and qualitative analysis like 2 days. Test for anion like 1 day. After this, we should discuss questions. In order to discuss questions, we need another 2 days. I mean, my section එක ඉවරලත් මම questions කතා කරනවා. Overall, taking entire papers and entire questions. Part wise also I'll be discussing, but at the end of this, as it's a 3 months course, I'll be discussing questions from the entire section also. Right? So then, tonight, like 13 days. If you get 14 days, it would be like 3.5 months. But it's perfect. Yeah, you don't want to suffer, you don't want to worry, because we'll be discussing the theories. Okay, and we'll be making a short note, discussing past papers, term test papers. You have to work really hard. I'm promise you මේ session එක මගෙත් එක පිළිවෙලකට ඉවර කරනවා. ආයි මේ session එක අමාරු කියන්නෙත් නැහැ. මේ session එක වෙන කොහෙන් හරි class එකකින් ඉගෙන ගන්න ඕන කියන්නෙත් නැහැ. මේ lesson එක හරි okay කියලා තමයි කිව්වේ. මොනවා ඔයගොල්ලෝ කියයි ටික පාඩම් කරගන්න ඕනි. ඉතින් මට කරන්න නැහැ පාඩම් කරගන්න එපා නේද? අමතක වෙන ඒවා පාඩම් කරගන්න ඕනේ. But you won't try to get this lesson again from another class or another or teacher, right? This is totally you will be satisfied from this. 100% I can guarantee. Okay. And then I don't start organic chemistry while I'm doing inorganic chemistry. In certain classes or in school, sometimes while they are doing inorganic, they will be starting organic. But I can't do that thing. Right? It's totally different. Right? Like swimming and 200 meters relay. Right? Then I can't get the 2 events at once. The relay kai swimming kai dekama ekata karana. Organic කියන්නේ swimming වල. මේක ඇවිල්ලා relay එකක් වගේ. හරි. මම වෙනස කියන්නේ. There's a difference. So then I won't do that. Right? So please do not expect that we'll be starting organic chemistry very soon. After finishing inorganic chemistry nicely, I'll be starting organic chemistry. Okay, organic chemistry. Organic and right. Okay, මුලින්ම කියලා ඉන්නද? නැත්නම් බෑ. Yes, that's right. Practicals. Common practicals කියන්නේ. So, if we get practicals, so there are practicals related to S-log, right? S-log practicals. So then you can write the practical number, right? Practical number and the practical name. ඉතින් name එක ලියා ගන්න පුළුවන් නේද? හරි. Practical number එක මෙතනදී ලියමු. දැන් ටිකක් වෙලා යනවා practical කොහොමද යන්නේ කියලා. I'll write the practical number. S-log. This way. Do not write anything. P-block practical number, D-block practical numbers, then cation test practical numbers, anion test practical numbers. What is there now? Hurry section ali sera liyamu sections වලටම practical test එක වෙනම ලියන්න. questions අහන්න. උදලට තියෙන ප්‍රශ්න අහන්න. මෙන්න S-log practicals. So what are the practicals that we are writing for S-log? When again I highlight කරන්න S-log practicals එක මුලින්ම. This one experiment number 9. Number එක කියන්නම්කෝ. Number එක 9. ඊට පස්සේ number එක 10. Number එක 11. Right? එතන විතරයි මම S-log එකට කියන්නේ. ගොඩක් කියන්නේ 9 10 11 ලියන්න. 9 10 11. ඉතින් ඔයගොල්ලෝ practical guide එක අරගෙන practical guide එකේ ෆොටෝ එකක් දාන්න 9 10 11 මේගොල්ලෝගේ names ලියන්න 9 10 11 තව තියෙනවා right after experiment number 9 10 11 මේ තියෙන තව හරි experiment number 16 testing solubility salts of S-log elements ඉතින් testing thermal stability of nitrates carbonates and S-log elements experiment number 16 and 17 is also from S-log 16 17 එකක් දාගෙන එසේ ගෙදර ලස්සන practical names ටික ලියන්න. මොනවාද 9 10 11 16 17 P block. P block means right group 3 to group 8. So then how many practicals in P block? Many numbers 12 13 14 15 12 13 14 15 12, 13, 14, 15. P block, right? Must say 12, 13, 14, 15. Then after that, colors of complex ions, this one ferrous, okay, potassium permanganate, copper 2 plus, yes, all these experiments, 18, 19, 20, 21, and then here 22, okay, manganese, and then 23 is only 22. Okay. This way, yes, 18 to 22. 18 to 22. Those practicals are D block practicals. Okay, mention karaga. 18, 19, 20, 21, 22. 18 to 22. Right. Then cation test anion test වල practicals තියෙනවද? තියෙනවා. මාර වැඩි කියන්නේ cation test anion test resource book එකේ නෑ. ඒක හැමතැනටම mix වෙලා තියෙන. කියන්නේ cation test anion test තියෙනවා නම් ඒක P block එකට ගිහින්. නැත්නම් D P block එකේ S block එකට ගිහින්. හරි. cation test anion test කියලා separate topic එකක් නෑ. ඉතින් ඉස්සර තිබ්බද? ඔව්. කලින් syllabus එකේ තියෙනවා. හරි. cation test anion test කියලා තියෙනවා. ඉතින් 2021 question එකක් අහනවා. resource book එකේ. හරි. resource book එකේ තියෙනවා ionic equivalent. Okay, then මේ තියෙන cation test වලින් අහලා තියෙන practical එක තමයි experiment number anion test එක. මේ තියෙන anion test එක. Testing the නෑ ඒක නෙමෙයි. පොඩ්ඩක් ඉන්න. මේක කොහොම හරි cation test. Test to identify nickel 2 plus ferrous copper chromium using sodium and ammonia. ඒක තමයි cation test එක. ඒ කියන්නේ 23 cation test එක. පොඩක් ඉන්නේ anion test එකක් මම දැක්කා. මේ හරි 11 එක anion test. ඒක S block එකට ගිහිල්ලා. එහෙමයි. කොහමද ඉතින් තියෙනවනේ නේද? anion test එක experiment number 11. හරිනේ. මට අර මෙතන පිළිවෙලක් කියන්නේ මම නම් කැමති නෑ ඔය mix වෙලා අර මේ උච්චලට් එක වගේ කතා කරන්න ටික. හරි ඒකයි මම ඕඩේ කරන්නේ. ඒක ළමයින්ට මේක ඉගෙන ගන්න ආසෙන් දෙනවා. S block practicals. P block practicals. D block practicals. cation test practicals. anion test practical මම මෙතන දෙන්න දින ඔබට පේන්නේ. anion test practical number 11. Is it clear? Right. එතකොට practical book එක print out එකක් ගන්න ඕනේ. හරි. book එකම ගන්න ඕනේ. මේ ටික විතරක් ගත්තා නේ. මේ ගන්න ඕනේද? ඔව්. හරි. ඒවා අපි ඉස්කෝලෙන් දෙන්නේ නැහැ නේද? ක්ලාස් එකෙන් දෙන්නෙත් නැහැ. හරි. සෙන්ටර් print out එකක් ගන්න ඕනේ. මේ practical පටන් ගන්න page number මෙන්න මෙතනින් පටන් ගන්න. හරි. 42 වලින් පටන් ගන්න. මම හිතන්නේ බඩ බලන්න book එක අරගෙන 42 වල ඉඳන් මෙන්න මෙතනට ලකන් යන්න. 73. sorry 73 නෙමෙයි. ඔව් 73. 73. එතන මේකෙන් පස්සේ තියෙන මොනවද? මේ තියෙන organic practical, මේ තියෙන equilibrium practical, ඔය equilibrium practical තියෙනවා කියන්නේ. මේ තියෙන අන්තිමට industrial practical. practical 44ක් තියෙනවා. ඒතර ඒවා ඕනේද? ඒවනේ එච්චරම අපි කරන්නේ නැහැ. practical ටික රිසර්ච් කරනවා. එච්චර මේ practical theory වලට questions වලට directly target වෙන්නේ. Those practicals will not be directly targeted to questions, especially physical practicals and industrial practicals. But this will be targeted because sometimes I'm checking whether from which section they have asked this question. දැන් මට A level question එකක් අරගෙන මම සමහරවිට බලනවා මේ question එක කොහෙන්ද අහලා තියෙන්නේ. research book එකේ කොතනද මේක තියෙන්නේ? බලන්න research book එකේ නෑ. right? research book එකේ හතරම ආයෙම නැහැ. හරි. ඉතින් මාත් confused වෙනවා. මොකද ඉස්සර අපි notes හදුවේ research book එකෙන් විතරයි. research book එකේ බලුවා note එක හදුවා. ඊට පස්සේ exam එකට ගියාම research book එකෙත් නෑ, අපේ note එකෙත් නෑ. සමහර පොඩි question එකක් තියෙනවා. හරි. මේ වෙන්න පුළුවන්. so ඊට පස්සේ මම ඒක experiment එකේ මම මේක ගැන හොයලා බලනකොට අහලා තියෙන practical guide. practical guide එකේ compound එකේ තියෙනවා. හදලා හදපු කෙනාට මොකක්ද කියන්නත් බෑ. ඒ නිසා මම classes වල practical guide එක miss කරන්නේ නෑ. ඒකත් discuss කරලා දාන්න. මේ compounds ටික හරියට උඩ අහු වෙනවනේ. practicals හරි. live කරේ නැතත් practical ටික post lab questions, pre lab questions එන්න කියවන්නේ, ටික print out එකක් ගන්න, ඒ වගේ එකත් අතාරින්නේ කරගෙන යන්න. හරිනේ? That's all. ඊට පස්සේ mention කරන්න in exam paper you're writing how many marks you will be getting for inorganic chemistry. For MCQs you get like 5 marks. 5 MCQs. Structured essay second question is available, second structured essay, and in the essay paper you get 9A structured essay, so essay 7B. So then I have considered 2021 A-level paper and given this, right? 2021 A-level paper karagena thamai denne latest paper. So then 5 MCQs means 5 marks. Second structured essay means 5 marks. Then here relatively you get marks for one essay question, that means 7.5. 7.5 plus 10 means 17.5. Nearly you get 20 marks. Right? Approximately you get 20 marks of your chemistry paper from inorganic. From organic you get more than 20, like 25 or 23. From physical you get more than 35%, right? 40% may A-level paper ke physical, right? Inorganic 20%, organic 25%, iduru tika general, right? Industrial uthiyana. Okay. So then I'll be erasing this, right? So you have write in exam paper, these are the questions that is targeted. 5 MCQs, second structured essay, and essay there are 2 questions. A-level paper ke inorganic kenne hema. Right. Now the next case, let's start. Chemistry of SPD block elements. So here SPD block elements, this term SPD is taken from the period table, right? The SPD period table. So then I will tell, okay, Last one question from you. So then, these are S-block elements, right? These are S-block elements. And then here, these are P-block elements. Make a unit 1 P-block elements. And then when you consider this category, it is from D block, right? I mean, this entire part is D block. And then here downwards, you have F block here, right? S block, P block, D block, and F block, right? Okay, what's my question? Why those elements are categorized under S block? Now, in S block, we have these elements: lithium, sodium, potassium, rubidium, cesium, francium. Right? This is group 1. When we consider group 2, beryllium, magnesium, calcium, strontium, barium, radium. Beryllium, magnesium, calcium, strontium, barium, and radium. My question: why we classify potassium and calcium under S block? Just I selected 2 elements. What is the reason? Why we classify elements under S block like this? Then why we are not classifying aluminium under S? What is the basis of classification under S block? Okay. Because, so let's read some answers. Valence electronic configuration. Valence electrons are present in S subshell, right? And their electronic configuration in the S subshell. Right. Yes, the reason. Thank you very much. Because the last electron belongs to S subshell. That's the answer. We have to consider the configuration of this as an example. Potassium, configuration, not your O-level configuration, A-level configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Potassium. Calcium, 4s2. So then their final electron, the last electron is filled to S subshell. That is what we are categorizing those elements under S block, right? S block. And then P block elements. So let's get nitrogen. So in the exam, if they're asking why nitrogen is categorized under P block, what's your answer? Why nitrogen P block is categorized? Very simple. Write the configuration and mention, okay, the block is, we have to select the block from the electron which is filling at the end. Ultimately, fill the electron in a block. Block consider. So then as an example, nitrogen, the configuration 1s2, 2s2, 2p3. So then the final electron is 2p. So in nitrogen, the final electron is a 2p electron. However, it's a p electron. So then that's what nitrogen is categorized under p. So then why these elements are categorized under D block? Now just imagine cobalt 27. Why cobalt is a D block element? Because the configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, the 4s2 can 20. After 20, we have to get 27. Then after 4s2, we get 3d7. 3d7. There. So that means we can clearly understand that cobalt is a D block element. 3d7. So what is F block? F block is also the same, but in A levels we discuss only about 54 elements. Okay, A levels elements 54. So then related to that category, F block elements are not, related or not available. Then we don't discuss F block elements under advanced level subjects and advanced level chemistry subjects. But in your university, you will be getting chemistry of F block elements in university level, right? In second year or the first year, second semester, you'll be getting it. Right. That's all from there. Right, the topic. We'll start S block elements. Under the S block elements, we have to write the content. Under the S block elements, in S block එකත් මම content එක දෙන්න. මොකද අද S block start කළා අදම finish කරන්න බෑනේ මේ. එහෙම කරන්න බෑ මම. I'll get like 3 days. Right. So then S block, what is the content? That's right. Periodic trends shown by S block elements. Periodic trends shown by S block elements. Right. Number 2. Reactions of S block elements. Reactions of S block elements. Reactions of S block elements with water, air, nitrogen, hydrogen, and acids. Well, reactions of S block elements. Reactions of S block elements with water, air, air, nitrogen, hydrogen, and acids. Nitrogen and N2, right? Hydrogen H2, acids, right? Okay. Number 3. Decomposition of S block salts. Decomposition of S block salts. Decomposition means heating. In your O levels, you should know calcium carbonate. When we decompose calcium carbonate, what are the products? That's called decomposition, right? Decomposition of S block salts. So within brackets, mention the salts: carbonate, nitrate, and bicarbonate. Formula stick में लिया carbonate, nitrate, bicarbonate. So under S block elements, S block cations, we are discussing carbonate, nitrate, and bicarbonate, the compounds formed by that. And then when we supply heat for those compounds, what are the products of it? When we supply heat for those compounds, what are the products of it? There, right. Decomposition of S block salts. Next one, solubility. Solubility of S block salts. That means we are getting a salt and adding it into water, and then we check whether it is soluble or insoluble. That is called solubility, right? අපි salt එකක් අරගෙන water වලට add කරලා බලනවා soluble ද insoluble ද කියලා. Right. Solubility of S block salts. Right. So then after this topic, number 5, right? Name of product demo. Number 5. Acidic, basic, and amphoteric. Acidic, basic, and amphoteric. Amphoteric means in between both, right? Amphoteric nature, acidic, basic, and amphoteric nature of S-block salts. Acidic, basic, and amphoteric nature of S-block salts. Acidic, basic, and amphoteric nature of S-block salts. That's it, right? But after this, you have to mention again practicals. මේක ඔයගොල්ලෝ හිතනට වඩා ලොකු ලෙසන් එකක්, right? මේක කොහොමද gas loss energetics වගේ නම් හිතන්න එපා. ඕනනම් හිතන්නේ calculations වගේ. මම කියන්නේ එච්චර කාලයක් යනවා. You'll be getting that much of a time period in order to finish this lesson because energetics and gaseous loss is like 1 month, but this is 3 months. And that's what I'm getting a good foundation, right? On the foundation එකක් දාන්නේ. Particles. So then you can mention the practical numbers. Especially I have to emphasize there's a practical called flame test, right? Flame test. The other practicals you can just mention the numbers, but flame test is compulsory. I mean, this is a well-known practical in this lesson, right? Definitely I have to mention flame test. So practicals, there are 4 categories. Flame test is one of the main. Right. So you can write the other practicals at home, right? Okay, have you finished? Shall I move to the next part? Please raise your hands. Okay, good. Thank you. I'll erase this, right? So this is the S-block content. S-block content. So which topic I'm going to discuss first? This topic. Period trends shown by S-block elements. Right? Number 1. Then I'll be finishing this and starting this also today. And I'll be discussing the reactions with water and air. And then maybe we discuss in the today's session. The next week's session I'll be finishing this and this. And then most of the times we can start S-block salts solubility also, right? Because I'm just giving a summarized note. Then you can read many more things from the research book also after I have done. Right? Man get not a first research book කියවන්න. ඒක කලින් කියවන්න එපා. හරි. මම කියනවා මම concept එක ඔළුවේ plant කරනවා. ඒකත් එක්ක research book එක කියවන්න. එතකොට ඒ ටික දෙන්න. හරි. ඒකයි වෙන්නේ. දැන් energetic research book එක කියවලා බලන්න. දැන් තේරෙනවා. ඒගොල්ලෝ කොහොම කිව්වත් ඒ ටික අපිට realize කරගන්න පුළුවන්. Right. But issues ඇති ඒක ටිකක් කල්පනා කරාම හවුවේ. Okay. Now I'll erase this. That's the topic. Periodic trends. Periodic trends of S-block elements. Periodic trends of S-block elements. So I'm going to write the S-block elements now. Right. Lithium, sodium, potassium, rubidium, cesium, francium. This do not write up. Good day, lithium, sodium, potassium, rubidium, cesium, francium. This side. Beryllium, magnesium, calcium, strontium, barium, radium. So this is group 1 and this is group 2. First question. There's an issue with this. So then I'm telling this is group 1 and this is group 2. So then can't you see any problem in group 1? I show the period table. There's a small issue with group 1 and my group 1. This is the period table, right? So you can see in the period table the group 1, and then in my chart the group 1. Right? What is the issue? Can you identify? Lithium, sodium, potassium, rubidium, cesium, francium, beryllium, magnesium, calcium, strontium, barium, radium. Right? Downwards the group you have to study. Then when we finish S-block elements, definitely you must say the elements downwards the group. Study it. Okay. Lithium, sodium, potassium, rubidium, cesium, francium. Beryllium, magnesium, calcium, strontium, barium, radium. What was the issue here? Under group 1. Yes. මම බැලුවේ මම ඒ වගේ අර ඔයගොල්ලෝ ඉන්ක්විසිටිව් ද නැත්නම් ඔයගොල්ලෝ මේකට සෙට් වෙලා දින්නේ කියලා හොයලා බලන්න. There's no hydrogen here. Yes. So generally in standard period tables we don't categorize hydrogen and S-block. Right? අපි blocks විදිහට separate කරනවා. ඔයගොල්ලෝ level exam එකේ period table එක hydrogen group අන්නලා තමයි තියෙන්නේ. Because it is not separated group block wise. S block, P block, D block, F block. But when we are categorizing S block in a standard period table, generally we don't classify hydrogen and S block. There are reasons for that. If you are classifying hydrogen, there are also reasons. You can make hydrogen S block එකට classify කරන්නත් පුළුවන් නැතුව ඉන්න. අර දැන් ඔය සමහර පළතුරු තියෙන එළවලුත් ගන්න පුළුවන්. පළතුරු කියලා ගන්නත් පුළුවන්. ඕල් මතක් කරලා බලන්න. එහෙම තියෙනවා. හරියට සමහරට මොන කැටගරිද කියලා හොයන්න බෑ. අනේ වගේ අය. So then actually why we are not categorizing hydrogen and S block? That's the main reason. First of all, tell me the reason to categorize hydrogen and S block. Hydrogen S block එකේ categorize. Why we must categorize hydrogen? You know, S block is the final configuration is S1 in group 1 elements, right? In group 1 elements, the common configuration is NS1. Group 2 elements, common configuration is NS2, right? NS2. So then what is N? N means what? N means, yes, period number. N means the number of the period. So if you want to write the configuration of rubidium, what is the final electronic configuration of rubidium? Now I can do electronic configurations in the first lesson. Rubidium, what is the final electronic configuration? The man of magic. Lithium, what is this period? Is it first period? You know, hydrogen and helium. Hydrogen and helium, they are in the first period, isn't it? So then lithium, beryllium in the second period. Sodium, magnesium, third period. Fourth period, fifth period. The rubidium in a fifth period. So the N means period number. So then you know for that group, common configuration is NS1 and N is the period number. So let's see, rubidium is fifth period, it is 5S1. The valence electronic configuration. Right? And let's just think you want to find the configuration of barium, the same thing. NS2, so this is in sixth period. There is 6S2. Make it and 6S2 divided by 6. Like 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10. Then 4P6, 5S2. Likewise, up to 5P6. So that is what we have to know. Right? So there are some things we have to confirm with this configuration. Okay, my question is, why we categorize hydrogen and S block? Because the configuration is same. If you get hydrogen, configuration is 1S1. In all the other S block elements also, configuration is S1. That's a reason for categorization of hydrogen and S block. There are some other reasons also. I mean, that's the main reason. Right? Research book basically generally discuss but think why we categorize hydrogen and S block? Because of the configuration. But in our study, we don't categorize hydrogen and S block. Can you give a reason for not categorizing hydrogen and S block? Yes, very good. This is the reason for the reason. Right. Now, Shweta, right? So we have given the first answer, Chatil. Vishmita, right? Okay. And then Vishma. Yes. It's not a metal. All S block elements are metals. Solids, metals. Okay. Metals. But if you consider hydrogen, it's a gas, it's a non-metal. That's the main reason. So we can categorize. Okay. Taking like that. So you should understand when we consider S block elements, all S block elements are metals and they are solids. That's the reason for not categorization of hydrogen and S. Right? So in a standard period table, I have seen both hydrogen and helium at the center, not categorizing under group 1 and group 8. Helium at group 8 එකට ගන්නේ. ඒ දෙන්නම center එකේ ඉන්නවා මම. period table to period table එක වෙනස්. Standard formal මේක තමයි බලන්න. Okay, now my topic is period trends. So across the period, what are the properties that get increased? Right? Across the period, what are the properties that get increased? We have to notice. Let's wait. Increases. And across the period, what are the properties that get decreased? Decreases. Okay. And then we should write downwards group. In the first lesson also we have written a thing like this. Downwards group. What are the properties that will increase from the day? Right. So we can mention use some arrows and mention these properties increases. And these are the properties that get decrease. We're making ගොඩාක් score කරන්න පුළුවන්. මේ පළවෙනි pitch එකෙන් මෙතනින් හරි. හොඳ score එකක් තියෙනවා. Related to inorganic. Right. So then actually let's get some properties. If we get some properties ටිකක්. Right here. Right. Number 1, if you get atomic radius. And then when you consider ionization energy, when you consider electronegativity, right? Melting points, boiling points, density, oxidizing ability, reducing ability, and electron affinity. Right? Electron affinity. So these are some trends. Okay. अब discuss करें. अंदर आ गया अरे. After this we will write the note. මේකත් එක්කම note එක ලියන් යන්න. ඉතින් enthalpy වල PV coordinate වල කරපුවාට මේක කරන්න බෑ note එක පස්සේ ලියනවා අහගෙන ඉන්නවා. හරි. මොකක් කර වැඩක් කරන ගමන් අහන් ඉන්නවා. මේක ටිකක් කල් යනකොට තේරෙයි. You have to give the maximum attention for the first 3 weeks in this S block because then you know what is S block, how to move with the questions. Otherwise, in this 3 months session, you'll be in a trouble. Number 1, atomic radius, where we have to write. Let's get across the period, atomic radius increases or decreases, and what is the reason? Across the period, atomic radius get decreased. Why atomic radius is getting decreased when you are moving across the period, like lithium, beryllium, boron, carbon, nitrogen, oxygen, thorium? The reason is nuclear charge. The number of protons available in the nucleus. So that, in lithium we have 3 protons, but beryllium 4 protons, boron 5 protons. So then higher the number of protons, higher the nuclear charge. From the nucleus, it is giving high positive charge. So then higher the positive charge, it will successfully attract electrons towards the positive charge. There will be positive charge electrons attracted. So as it is attracting electrons towards the positive charge, what you can understand, right? As it is attracting electrons towards the positive charge, what you can understand, attraction of electron towards the positive charge means decrease in the radius. So actually radius means the distance between nucleus and valence shell. So when we move across the period, atomic radius get decreased. Downwards group, what will happen to the atomic radius? What is the reason? How to think? I've given the time. Downwards group, what will happen to the atomic radius? This thing decreases or increases. Then think of the reason. Then when I'm telling the reason, you can confirm your reason. Whether is it the same? Should think about the main reason. Main reason එක තමයි ගන්න ඕනේ. Number 1 reason. So then atomic radius, the first lesson we have discussed that when we move downwards group, atomic radius get increased. Atomic radius get increased. What's the reason? Number of energy levels. Downwards group, you will increase the distance between nucleus and valence. You have to say this, right? Since the number of energy levels are getting increased downwards group, the distance between the nucleus and valence shell is also getting increased. So as the distance between the nucleus and valence shell is also getting increased, we say atomic radius is increased. The atomic radius is increased. Right. Next one, ionization energy. I'll give reasons. I mean, you can ask questions in Zoom chat. I can give the reasons. You can give give answers for your questions. Please keep the question here. Ionization energy. Across the period, ionization energy will it increases or decreases? Can remember? In zigzag manner. Right? So when we are saying increases, we have to be very careful. That is not a gradual increase. Ionization energy increases කියලා කිව්වොත් ඒක මට උන වැරදි කියලා ගන්නත් පුළුවන්. Generally it is increasing. ඒක හරි. ඒ වගේ term එකක් කියලා generally it's increasing, but it is not gradually increasing, right? I mean increasing, decreasing likewise. So then how we say? We can say ionization energy increases. Okay? But within brackets we have to say zigzag. Right? Ionization energy. Within brackets we have to say zigzag. Actually, why the ionization energy of let's get neon is higher than lithium? Why the ionization energy of neon is higher than lithium? Ionization energy means the amount of energy that we have to supply. Endothermic, right? That we have to supply when an electron is removed and making a positive ion. So then this ionization energy entirely depends on the radius, shielding effect, and then the charge, right? The electronic configuration. Then you can understand when we remove electron from neon and when we remove electron from lithium, which becomes stabilized, which becomes destabilized. So then we can't easily remove an electron from neon because it is having very stable configuration, 2s2 2p6. Then when we are trying to remove an electron from neon, it is asking for more energy. That's the reason. So then you can explain it using configuration. Okay. Downwards group, what will happen to ionization energy? The group එකේ පල්ලෙහාට මොකද වෙන්නේ ionization energy? Downwards group. Just recall, what is the reason? Ionization energy means the amount of energy that we have to supply in order to remove the outermost electron, in order to take out the outermost electron, right? In order to give out the outermost electron. So then downwards group, you know, by heart කරන්න ඕනේ නැහැ පොඩ්ඩක් logically හිතලා තිබ්බනම් නිකම්ම මතක හිටියි. By heart කරන්න ඕනේ. Ionization energy downwards group, it should be getting decreased. Because easily you can remove electrons when you are moving downwards group. Why? Because the attraction between the nucleus and valence shell electron get decreased. So the attraction between the valence shell electron and nucleus will get decreased when you move downwards group. Why? Because when you are moving downwards group, you get more energy levels. Okay? 2 energy levels, 3 energy levels, 4 energy levels, 6 energy levels. Then the valence shell electron එකනේ අපි අයින් කරන්නේ. නැත්නම් ionization කියන්නේ nucleus එක ළඟම තියෙන electron එක remove කරන එක නෙමෙයි. Then when you are removing the electron from the outermost shell, it is considered with the interaction between the nucleus and outermost shell. So downwards group, it is getting decreased. The interaction between the nucleus and the valence shell get decreased. That's one point. So then the amount of energy required to remove the final electron will get decreased. So ionization energy get decreased downwards the group. So මේවා අහනවා එහෙම explain කරන්න. මොකද MCQ එකක reasons වගේ අහුවොත් තමයි නැත්නම් මෙච්චර simple questions inorganic වල L වල අහන්නේ නේ. but මේ background එක තියෙනවා. හරි. ඒගොල්ලෝ හිතනවා නම් මේවට reasons උත් ලියන්න ඕනේ කියලා question book එකේ ලියන්න. notebook එකේ ලියන්න ඕනේ නැහැ. හරි. question book එකේ ලියුවට කමක් නැහැ. Ionization energy increases. Reason. Ionization energy decreases. හරි. downwards. Reason. extra වැඩ. ඒතර මේ සතියේ වැඩිපුර inorganic homework නැහැ. අර enthalpy වගේ ඉතල කරන්න තියෙන්නේ paper class එකේ paper කරනවා නම් එහෙම කරනවා ඊළඟ මේවට මම කියන extra වැඩ ටික කරා question book එකේ ඒකට research ලියන්න ඒක හරිද කියලා බලන්න ඉන්ටර්නෙට් එකේ search කරන්න english medium වල ඉන්ටර්නෙට් එකේ search කරන්න පුළුවන් වෙන කවුරුත් නැහැ මේ සිංහලෙන් මේ comment search කරා අයනීකරණ ශක්තිය වැඩි වීම ආවර්තයක් ඉදිරියට කෙලෙසද කෙසේද ඔහොම ගැහුවම මුකුත් වෙන්නේ කවුරුද ඔයාලා ලියලා තියෙන්නේ ඒක නිසා දැන් ඒගොල්ලෝ ඊට පස්සේ ට්‍රාන්ස්ලේට් කර කර තමයි ටයිප් කරන්නේ. but English medium එකෙන් කිසිම දෙයක් එකක් නැහැ. ඉස්සෙල්ලා ටයිප් කරා voice typing උනා. ඕන තරම් ඒවයි. අර සිංහල medium එකේ මම terms දන්නෙත් නැහැ. සමහර අය කැමති නැහැ terms අහන්න. ඒ නිසා අපිට ලොකු opportunity එකක් තියෙනවා මේ ඉන්ටර්නෙට් එකේ මේවට මාර විදියට explanations තියෙනවා. අපිටත් මේවා බැරි වෙලා වෙලාවට ඕන තරම් තියෙනවා. මේ ඉන්ටර්නෙට් එකෙන් තමයි ඉතින් රිෆර් කරලා ගන්න. පොත් කියවන්න දෙයක් නැහැ. ඉන්ටර්නෙට් එක පොඩි. Ionization energy. Next one, electronegativity. Electronegativity. Actually, what is electronegativity? Right. So, what is electronegativity? We should consider electronegativity means ability to attract electrons. And electronegativity means ability to attract bond electrons. Can you remember the electron that is having? Can you remember the species which is having highest electronegativity according to the Pauling scale? Which element has highest electronegativity? Is very good. Right. Fluorine. That means across the period, definitely electronegativity is getting increased. Fluorine in the pattern. Across the period, fluorine electronegativity is getting increased. Why the ability to attract? Why the ability to attract bond electrons will get increased when you move across the period? What is the reason? Why the ability to attract bond electrons get increased when you move across the period? That's the reason. This is the nature. Now, generally, when you get S-block elements like lithium, beryllium, boron, these elements, they are removing electrons. Right? I mean, they are removing electrons and they will make positive ions. මේගොල්ලෝ කැමති electrons අයින් කරලා stable. එහෙමනේ configuration set වෙලා තියෙන්නේ. 282. Just removing final electrons and getting the configuration 2A. But when you are moving to this side, you get anions while they are willing to gain electrons and being stable. Now, the example like chlorine 287. I'm making all level configuration. Okay? 287. Then how chlorine will become stabilized? By moving to argon's configuration. 288. So 287 can get one electron and it is converted into 288. So 288 is a very stable configuration. So then it is gaining an electron. That's the reason, right? So then when you move this way here to here, the ability to make cations will get decreased. Cation has an ability, positive charge. The ability to make cations will get decreased and the ability to make anions will get increased. You see, electronegativity element our reasons for electronegativity we can give many more reasons. Adversation, oxidation of the charge. Right. Then you know downwards group what will happen to electronegativity? Downwards group electronegativity increased or decreased. That's the reason. Decreases. Why electronegativity decreases downwards group? What's the main reason? Ability to attract electrons will get decreased. Electronegativity decrease when we move downwards group. Yes, the same reason. When you move downwards the group, the distance between nucleus, valence shell electrons. මේ valence shell එකේ electrons නේ bonds හදන්නේ කොහොමද? then we have to consider the attraction of valence shell electrons with nucleus. So if those are well attracted, it's difficult to attract it by another atom. That's the reason when you move downwards the group, the distance between the nucleus and the valence shell electrons get increased, so then the attraction is reduced. Right? Attraction is reduced. So then electronegativity is the ability to attract bond electrons, so then that one will also getting decreased for a certain atom as it is having high distance between the nucleus and the valence shell electrons. එයාගේ size එක වැඩි වෙන එයාට අනිත් electron එක attract කරගන්න තියලා එයාගේ electron එකටවත් attraction එක කරනවා. Just think HCl, HBr, HI. So then chlorine, bromine, iodine. So when you move downwards the group, electronegativity is getting decreased. Why? Because the distance between the nucleus and the valence shell electron is getting decreased. Then it is very difficult to attract even its own electron than attracting the other electron. Right? That's the reason. Size එක වැඩි වෙනකොට බෑන් ජීව පප්ප වගේ මිටර් size එකක් විතර දැන් කොහේ attract කරන්නේ. මේ ඒ වගේ scene. Now the next one, melting point, boiling point. And factors क्या थे? Melting point, boiling. Across first the period, downwards the group. What will happen with the across first the period? Increases or decreases? Which element has highest melting point? Always have a comment. Which element has highest melting point? Yes, carbon. Carbon and silicon, they have highest melting points, especially carbon. Because in carbon, there's a state called diamond. So, you know, diamond is a rigid structure. And then when you convert that solid to liquid, the energy that we have to supply for diamond is comparatively high. Right? So then in diamond, that is having a high melting point. Okay? And then we say the boiling point is also comparatively higher in the carbon and silicon. So what you can understand, from group 1 to group 4, group 1 to group 4 with the right, melting point, boiling point increases, then decreases. Carbon වලින් පාඩම් කරගන්න. මම හැම වෙලේම පාඩම් කරගන්න විදි කියනවා. මම මතක තියාගන්න මොකක් හරි විදිහක් තියෙනවනේ. ඒකම කියනවා. හරි. ඔයගොල්ලෝ ඊටත් වැඩිය ලේසියෙන් මතක තියාගන්න මෙතන එකක් හදාගත්තා නම් ඒත් පුළුවන්. මේ এডুকেෂන් එකේදී මේ process එකේදී ඔයගොල්ලෝ මතක තියාගන්න ටෙක්නික් හදන්න ඕනේ. ඒව සමහර ක්ලාසස් වල කියන්නේ. සමහර ඒවා කියන්නේ. හරි. මටත් සමහර ඒවා කියන්න බැරි වෙනවා. බට් මට වැඩි ඔයගොල්ලන්ට එහෙම ටෙක්නික්ස් හදන්න පුළුවන්. මම ඒ ලෙවල් වල ඉගෙන ගත්තට වැඩිය මම දැන් වෙනකොට ටෙක්නික්ස් ටිකක් හදලා තියෙනවා. මතක නැතිව මතක තියාගන්න. ඔයගොල්ලන්ට එහෙම සමහර සර්ලා කියනවා ඉස්කෝලේදී අහනවා මේ හැම එකක්ම කන්ටැක්ට් කරගෙන memorize කරන techniques develop කරනවා. ඒකයි වෙන්නේ. Now here, you know, carbon diamond is having high melting point. So then group 1 to group 4 melting point is increasing. Then it's decreased. Why melting point is increasing in group 2 than group 1? Melting point depends on, these are metals, the metallic bond strength. Metallic bond strength. If you get lithium and beryllium, which one is having high metallic bond strength? Do you know the factors affecting to metallic bond strength? Okay. Metallic bond strength eකට affect වෙන factors දෙකයි. Charge කියන්නේ මෙතකේ positive charge. Metallic bond means positive charge cation having the attraction with electron. Okay. Charge, and then the next feature is radius. Right? Charge and radius. Is it there? So then higher the charge, higher the metallic bonding strength. Higher the charge, higher the metallic bonding strength. What about the radius? Will it be higher or lower? Okay. Radius එක වැඩි වෙන එක හොඳයිද metallic bonding වලට අඩු වෙන? Okay. Now keep remember two cations, like okay, this much of a cation and this much of a cation. So then when the size is increasing, the positive charge is distributed. It is not centralized. Then you can't attract more electrons towards yourself. Just think a magnet with very high power. If it is having very high radius, the power is getting decreased because, I mean, it's having large type of a size. But if it is compact, it's a small one having the same power, it can attract more species towards that because the distribution is minimized. Then here also I must say, when you consider two cations, the cation with the lowest radius will have high amount of attractions with electrons because that positive charge is not easily distributed. It's centralized. So it can attract more electron towards that side. That's the reason. So then when you consider radius, it should get decreased when you increase the metallic bond nature. Right? So then always, how we say beryllium is having more melting point and boiling point compared to lithium. Why is it? Easily, no need to think about the radius, right? Radius is not the point. Charge is the point. Lithium, it forms Li plus cation. Beryllium forms Be2 plus cation. Higher the charge, higher the ability to attract electrons. I mean, higher the metallic bonding nature, higher the metallic bonding strength, right? But the species with highest metallic bonding strength, like aluminium, like I mean from the charge, right? Lithium, beryllium, and aluminium. Aluminium වල වගේ දෙකම හරිය. Radius එකත් low, charge එක L3 plus. Metallic bonding strength, right? Plus 3. Then downwards slope, what will happen to melting point boiling? Will it increase or decrease? Downwards slope. Now sodium plus and then rubidium plus. Do you think in which one we have high melting point and boiling point? I mean the metallic bonding strength, the charge is same. But what about the radius? Downwards group radius is increasing. So when the radius is increasing, I told that the metallic bonding strength, radius එක වැඩි වෙනකොට metallic bonding strength එක අඩු වෙනවා. Radius එක අඩු නම් තමයි metallic bonding strength එක වැඩි. So මේක note එකක් කොහෙද තියෙන්නේ? unit 2 වල ලියවන්නේ metallic bonding strength කියන්නේ. ඒක මම මේ properties වල increase decrease වෙනවා කියලා විතරයි ලියන්නේ. If you won't write this in addition, you can just collect the recording of this session and you can write it as a note. I mean, in your questions book. But don't add this one to your notebook. Right? You can refer in the internet and you can write more reasons. That's allowed. Right? It's okay with this. I mean, these properties you can search. Again, very good. Right? In A-level, there's a book called data book. Right? From the data book, you can get the values. Radius of sodium, radius of potassium. Then from the values also, you can just study. This book came values can right, that's what I have to say. Right. So when you move downwards slope, we say melting point, boiling point decreases because the radius is increasing, and so then the metallic bonds will get decreased. Okay. What about density? Actually, density means mass over volume. So then here the mass is affected. When you move across the period, we say the density is increasing since the mass is increasing. Okay. When you move across the period, we say the density is increasing. And then downwards group also relatively the density is increasing, but it's getting changed. Right? I'll show some variations with data. Actually, I want to discuss the last two. Electron affinity. What is electron affinity? Electron affinity and electron gain energy means two concepts. But in A-levels, we are considering it generally the same. Like acceleration, deceleration. Electron affinity means the amount of energy released or the amount of energy gained when an electron is taken by a gaseous atom to make a uninegative ion. So in electron affinity, what will happen with the across the period? Across the period, electron affinity is getting increased. If you compare lithium with fluorine, definitely fluorine is having high electron affinity value. Right? Fluorine electron affinity value is lithium to fluorine. Why is that? Because the configuration. When you gain an electron, lithium will not become stabilized. But when you gain an electron towards fluorine, it is being stabilized. So it is releasing the energy. Right? Lithium is releasing less amount of energy. Releasing the energy means being stabilized. Absorbing the energy means being destabilized. Right? When you go downwards loop, what will happen to electron affinity? This is bit complex. Downwards loop electron affinity is bit complex. From second period to third period, generally, not this, right? I mean, especially in oxygen, sulfur, fluorine, that side. We can make side okay. Second period to third period, electron affinity is getting increased. I mean, it is releasing more amount of energy. But downwards group, furthermore, electron affinity get decreased. Just think group 7. Fluorine, bromine, iodine, astatine. Group 7 වගන්න වෙනම ගුත් ඕනේ. Fluorine and chlorine. Which one is having high electron affinity? Fluorine or chlorine? Electron affinity means the amount of energy released when an electron is gained. Both fluorine, chlorine, bromine, and in all these species will release energy. They will not absorb. I mean, there are few elements that they will absorb energy. Beryllium, nitrogen, magnesium, noble gases. First electron affinity is positive for those. But for fluorine, chlorine, bromine, iodine, we can't say first electron affinity is positive, it's negative. I'm asking, when you consider fluorine and chlorine, which one is having high electron affinity value? Fluorine. ඒ කියන්නේ ෆ්ලෝරින්ට වැඩිය පුතා ෆ්ලෝරින් ඉලෙක්ට්‍රෝන එකක් ගන්නකොට ස්ටේබල්. බලන්න මේක මාර වැඩි. ඇයි? Because fluorine is the element with highest electronegativity. ඉතින් ෆ්ලෝරින්ටනේ හොඳටම ඉලෙක්ට්‍රෝන්ස් ගන්න පුළුවන් වෙන්න ඕනේ. නේද? But actually, when fluorine is gaining electrons, it is not becoming stabilized like chlorine. Fluorine ට ගන්න පුළුවන්. ගත්තට stable. But chlorine, okay, from the value, it is not saying that it can gain electrons, but after getting electrons, it is becoming stabilized. Why it is becoming stabilized? Because the space. In fluorine, even it can gain electrons, it is not having a sufficient space to keep that electron as having just 2 energy levels. In fluorine, there's only 2 energy levels. So there's a huge repulsion between the electrons in the valence shell. There are only 2 energy levels. So අලුතෙන් එන electron එකක් එන්නේ අර second shell එකට. There's a huge repulsion. So then due to the repulsion, we say the stability is decreased. But think of fluorine. In fluorine, you have 3 energy levels. Energy levels තුනක් තියෙනවා. So then when a new electron is gained towards the third shell, අලුත් shell එකට electron එකක් ගන්නකොට, we say the repulsion is minimized. Right? We say the repulsion is minimized because there's a sufficient space between the nucleus and the valence shell. As it there, there's a proper space between the nucleus and the valence shell. So then we say repulsion is minimized. That's the point. Right? So then fluorine to chlorine, electron affinity is increased. But after that, fluorine, bromine, iodine, downwards the group. In 2017 A-level exam, they are asking this electron affinity trend. That's the trend. Fluorine, bromine, iodine. Right? But in 2017 paper, in 2022 classes, we have discussed 2017 paper today. Right? We have finished the syllabus and we are discussing papers now these days, right? So then we are discussing MCQs, structural and acids. So then we discuss 17. So I'm telling fluorine, bromine, and iodine. When we move downwards the group, electron affinity is getting decreased. What is the reason for that? Just think. Why electron affinity is getting decreased after chlorine? Fluorine to chlorine, it's a abnormal trend, exception. But after chlorine, the general trend continues. Fluorine, bromine, iodine. What is the reason? Affinity means ability to attract electrons, not release. You are trying to gain an electron. In order to gain an electron, there should be a support from the nucleus, isn't it? So the nucleus again support එකක් තියෙන්නේ. But when you move downwards the group, the support, the backup from the nucleus is getting decreased. Why? Because you are getting electrons to the valence shell. And when you consider the distance between the nucleus and the valence shell, actually the valence shell and the nucleus, the distance is getting increased. Then can we say the nucleus will attract the final electron? අපි electron එක ගන්නකොට ඒ ගන්න electron එක nucleus එකෙන් attract කරයි කියලා අපිට හිතන්න පුළුවන්. බෑ. We can't say the nucleus will attract that additional electron. Is it there? That's what always we say downwards group electron affinity get decreased because it is not becoming stabilized after gaining an electron. Why? The interaction between nucleus and final electron. The interaction between nucleus and the final electron already decreased. Okay. When you're moving downwards group. Is it clear? Right? Just keep it in your mind. Right? Question book period trends lesson එක අපි කරපුවා. ඉතින් note එකේ ලියලා තියෙනවා. ආයෙ හැම ලියන්න ඕනේ කියලා හිතනවනම් additional activity එකක් විදිහට question book එකේ ලියන්න. note එකේ නම් ලියන්න. මොකද හිතන එක හොඳයි. So then is it clear? Downwards group, what will happen to the electron affinity? Second period to third period it increases, then it get decreased. Yeah, right. I'm asking another question. Oxidizing ability. Right. So you know, when you are moving this way, fluorine is the species which is having highest electronegativity. Right? I'm discussing about oxidizing ability. Fluorine is the species that is having highest electronegativity. So then just think I'm fluorine. So I'm fluorine. So then I can gain more electrons, isn't it? Fluorine ගේ electronegativity වැඩි කියන්නේ පොත fluorine electrons ගොඩක් ගන්න පුළුවන් කියන එක. So fluorine will gain more and more electrons towards itself. Is it reduction or oxidation? Is it reduction or oxidation? Fluorine is having highest electronegativity. It can gain more electron towards itself. Is it reduction or oxidation? Very simple. හැමෝම answers දෙන්න ඕන. හරි. මේ වෙලාවේ news බලන්න. මේකට බලන්න. So then fluorine is gaining electrons. So then when it is gaining electron, what you should understand, it is reduction. Very good. Right? Good. That is reduction. So then fluorine undergoes reduction itself. Reduction means gaining electrons. So when fluorine is gaining electron towards itself, what will happen? Okay. What we can say, is it oxidizing agent or is it a reducing agent? Just think I am undergoing reduction. Then mama reduced it. Then mama reducing agent, the oxidizing agent. I have explained about this term previously, the term agent. And then redox quality, right? Agent. You know, traveling agents. And traveling agents are what? Traveling agents will not travel. Traveling agents will help the others to travel by issuing some tickets, making the visas, right, and giving the destinations and the information related to the things. Right? Traveling agents. They will put on the foreign embassy or traveling agents. They will travel. Right? So in case they will travel, but their purpose is what? To allow others to travel, to allow others to migrate, right? That is agent. So then here, oxidizing agent. Oxidizing agent means a species which will allow another species to get oxidized. Getting oxidized means releasing electrons. In order to release electrons, there should be a species which will gain electrons. කවුරු හරි කෙනෙක්ට electrons අයින් කරන්න නම් ඒ අයින් කරන electrons ගන්න කෙනෙක් ඉන්නවා. There should be a species which should be readily available to collect those electrons. So then what is my point? If there's an oxidizing agent that will oxidize another species while it undergoes reduction, that means it gains electrons. So what do you have to say? Fluorine, is it an oxidizing agent or reducing agent? Fluorine, is it oxidizing agent or reducing agent? Yes, very good. Receiving answers from you. Good. It's an oxidizing agent. One. It is the strongest oxidizing agent. හොඳම oxidizing agent එක තමයි fluorine. Because when you move this way, fluorine is the species with highest electronegativity. It is the species which can gain electrons well. So then it is the species which can reduce well. If it is reducing itself well, it should make another species to be oxidized. වෙන කෙනෙක් oxidize කරන්න හොඳටම පුළුවන් වෙන්නේ හොඳටම reduce වෙන කෙනෙක්. මට හොඳට reduce වෙන්න පුළුවන් නම් මට පුළුවන් වෙන කෙනෙක්ව හොඳට oxidize කරන්න. So then the best oxidizing agent is the species which will reduce well. Right? So across the period, what we can see, which properties increase? Is it oxidizing ability or is it reducing ability? What's your answer? Across the period, is it oxidizing ability or is it reducing ability? Which properties increase? It's very good. Across the period, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Which properties increase? Oxidizing abilities. Keep remember fluorine. Fluorine is the strongest oxidizing agent. So across the period, oxidizing ability increases. The ability to act as an oxidizing agent will get increased, right? So at the same side, you can say reducing ability decreases. When oxidizing ability increases, reducing ability increases, right? They are inverse. Right? So when oxidizing ability is getting increased, the reducing ability is getting decreased. Is it there? Right. Downwards group. What you can see? Downwards group. Now, my question. When you consider sodium and rubidium, which species can release electrons easily? Is it sodium or rubidium? When we consider sodium and rubidium, which species can give out electrons easily? Yes, we're getting some answers. Really good. So we have to think logically and give answers. අපි මේ පාඩම් කරන්නේ පාඩම් කරන්න ඕනේ හිතලා උත්තර දෙන්න පුළුවන් ඒවා අහන්න. හරි මොනවද පාඩම් කරන්නේ? Sodium and rubidium. And then which species can give electrons out easily? So then that depends on the interaction between the nucleus and valence. Interaction between nucleus and valence. So you know clearly when you move sodium to rubidium, the attraction between the nucleus and the valence is getting decreased. So then rubidium can remove electrons easily than sodium. So which one will oxidize easily? How the lithium oxidize when? Is it sodium or rubidium? Rubidium. So what we can see, which one is what will happen to the reducing ability? You know, a species which is having a reducing ability should get oxidized itself. So then downwards group, the ability to oxidize. Downwards group, the ability to oxidize will get increased. Right? So we say reducing ability. Oxidize වෙන්න තියෙන හැකියාව chance එක potential එක වැඩි වෙනවා කියන්නේ අපි ඒකට වෙන term එකකින් කිව්වොත් කියන්නේ reducing ability increases. So then what is the strongest reducing agent? Is it lithium or francium? What is the strongest reducing agent? Lithium or francium? Francium. Right? Unfortunately, we are not discussing about francium and radium because these are radioactive elements. Half-life is very low. We can't even see these elements. But not that because they are radioactive elements. Right? Naturally, they are not available. They are in a radioactive series. But cesium, barium, rubidium, strontium, these are available. But these elements are not available as solid elements. Separate elements. They are making compounds. You know, sodium is available as a sodium chloride. You can extract sodium. Right? It's available, but generally they are highly reactive. They make compounds and they are available as those compounds. But okay, I have finished that discussion. Right? Again, discussions then. So in here, what I have explained, the properties that they are increasing and decreasing upwards and downwards. So we have discussed what are the properties: atomic radius, ionization energy, electronegativity, melting point, boiling point, density, then electron affinity, oxidizing ability, and reducing ability. Okay, so we're going to write it. Get your notebook. Please write at the same time. So in our classes, we are sharing a note also as a support to you. So this is the note. Can you see? Right. So then you can write in your own way. This is common configuration. Okay. Common configuration. There's 8 properties you have to write. Just keep the space and manage it, and you can start writing this. Right. One more thing. For group 1 elements, there's a common name. What is that name? For group 1 elements, there's a common empirical name. Can I give any name for group 1 elements? Yes. Vidunita, right? I have given the answer. That's correct. Downwards group 1 elements, right? 11. Downwards group, this when you consider this group 1 elements, not downwards group 1 elements are called alkaline elements. What is alkaline? What is the meaning of alkaline element? Right? Alkaline element means these elements can form bases. Elements වලට තියෙනවා bases. Sodium hydroxide, potassium hydroxide, rubidium hydroxide. Those bases are but well soluble in water. Okay? These elements will make bases, will produce bases that they are well soluble in water. So the make the bases are not the water soluble. Most elements they are not forming water soluble bases. As an example, magnesium. If you get magnesium hydroxide, that is not water soluble. It's water insoluble. We consider magnesium hydroxide as a precipitate. Right? So that's what the reason. Group 1 elements are called alkaline elements. Right? Got that? alkaline elements. Alkaline. Group 1 elements are called alkaline elements. The reason is they form water soluble bases. Water dissolve in a bases. Right? Then when you consider group 2 elements, what's the name? Group 2 alkaline earth elements. Alkaline earth elements. Alkaline earth elements. What is the meaning of alkaline earth elements? They are found in earth crust. The following magnesium. It is found as magnesium carbon, calcium carbon. Okay? I mean marble, granite, dolomite. Naturally available minerals are available as these elements. And sodium is earth crust again. Sodium is available in seawater. So then, when you consider these species, most of the species are found in earth crust, not as the pure element, but as a compound, like a carbonate or oxide. That's what we say. They are alkaline earth elements. I mean, those elements are also water soluble. Right? They are forming water soluble bases, but not all. At all, magnesium hydroxide is water insoluble. One may given elements water soluble. Very simple. They are given. They are forming bases, hydroxides, which are formed well dissolved in water. Group 1. Right? These are found in earth crust. Okay, let's write. Please note. I'll give 2 or 3 minutes. Please complete. ඉගෙන ගත්ත වෙලාවෙම note එක ලියන්න. හරි. ඒකයි වෙන්නේ. Any questions? If you have any questions, please ask in the Zoom chat, right? I can give the answers. Right. Please write the note. Hydrogen is not considered as an alkaline element even here, right? Yes, hydrogen is not forming a hydroxide, right? It's water only. So hydrogen alkaline element alkaline elements metals with that. Right. Any more questions? So then I have written 8 properties. Just consider whether 8 properties are available here. Sometimes it's reduced, right? Just consider. Could you please zoom it a bit? Make a zoom කරන්න පුළුවන්. එතකොට මෙන්න මේ මේ ටික මොලෙන් තියලා ඉන්නන්නේ. ඊට පස්සේ අනිත් ටික ලියන්න. මම මේක finish කරගන්නකො. properties reactivity ආමඩ එක කියන්න බැරි වුණා නේද? හරි. චුට්ටක් ඉන්නවද? 1 minute. Now reactivity කියන්න ඕන එකක් නේ. When you move downwards, what will happen? මේ slope එකේ කරන්නේ මේක check කරන එක තමයි. මේ slope එකේ ඔක්කොගෙම check කරන්නේ reactivity. So you know downwards slope, reactivity of what? Reactivity of these elements will increase. Sodium කැලක් වතුරට දාන්න. Potassium add into water. Then you will see how the reactivity. Right? Reactivity is definitely increased because they can easily oxidize. They are easily oxidized. They can easily remove electrons. So then we say reactivity is increased. But when you consider these group 2 elements, gradually the reactivity is decreasing. And sodium, magnesium, adding a piece of sodium to water, adding a piece of magnesium to water. And magnesium can react with it. Right? I mean, we have magnesium, it's even not reacting. Magnesium na monotaram hagana pulwa. Magnesium gana tibe mumme. Pena elements practicals karana thina. Magnesium doesn't react with cool water. But if you get sodium, it is highly reacting with cool water in a great rate. I mean, the rate is also increased. Sodium kala padru damana merry go round yana wage. Pena visuals thiyena honda deva. So definitely this way reactivity decreases. Sodium, magnesium, magnesium cool water react karane sodium merry go round. Downwards group, the reactivity is increasing because it is easy to oxidize. It is easy to remove electrons when an energy level is at right. Okay, that's right. You have finished this. Raise your hands, right? Otherwise, I can't see. What a pin, eh? Right. Have you finished? Done. Why radium and francium have same atomic number? Atomic number is same dagana. Francium 87, radium 88. Right. This is a real period table. So you can see that. Right. So then make it 88. Put mistake below. Right. So this is the common electronic configuration. N is the period number, and this period number. This second period. Second period. First period. Third period. Fourth. Fifth. Sixth and seventh. මෙතන ඔක්කොම ප්‍රොපර්ටිස් තියෙනවා මෙතන නැති ප්‍රොපර්ටි එකක් මොකද reducing ability තියෙන oxidizing ability නැහැ ඔන්න reducing ability increases මෙතන ලියා ගන්න පුළුවන් oxidizing ability decreases oxidizing ability decreases මේ පොඩි ප්‍රශ්න melting point boiling point decreases කියලා තියෙන්නේ electronegativity decreases ionization energy ionization energy just wait reactivity increases that's okay reducing ability increases atomic radius I mean this arrow is just I mean right we have to change that side right I mean increases decreases right so now here in this one let's make this one as decreases I mean first period sorry I thought this is across first period right sorry issue with me this downwards group so the downwards group reactivity increases reducing ability increases atomic radius increases density increases electronegativity decreases ionization energy increases melting point boiling point decreases sorry for the disturbance next one across the period electronegativity increases density 1 to 2 group 2 increases ionization energy increases oxidizing ability increases decreases reactivity and atomic radius ask questions if you haven't finished this part you can take a screenshot right screenshot okay ask questions downwards group oxidizing ability decreases right oxidizing ability methane across the period across the period downwards group oxidizing ability decreases if you want you can write another point oxidizing ability decreases downwards group right you have finished done okay great so we have discussed almost all the topics here oxidizing ability reducing ability melting point boiling point electronegativity. So then in your questions book, you can do it as an exercise. The reasons for these features. Right? What are the features for the atomic radius decreases across the period and the increases downwards the loop? You can write comments as questions. You can do it in the questions book. Okay. Now we are starting the next session. Right. Next session we are going to start by the topic. The second topic, reactions of S-block elements. Okay, so leave the content ready. Reactions of S-block elements is the topic you have to follow. It is enough to write reactions of S-block elements. Right. Then right. Now from this part you get past paper questions from this part. Right. Directly you get past paper questions from this part. Now we are discussing these reactions of S-block elements. Right. Reactions of S-block elements as a chart. So in the today's session I'll be discussing about the reactions of S-block elements, basically with water and oxygen. Okay. And then in the next day's session we can discuss about hydrogen, acids and bases, acids. Right. Then in this case, in this lesson, you will be learning how to memorize the things. Right? What are the trends? So then I thoroughly emphasize that it is better to attend these classes properly. Okay. At least try to attend 4 days properly, then you will understand what is inorganic. Otherwise, definitely you have to regret. Among Godak students la. අපේ classes අප නැති අය මුලින්ම sessions purchase කරගන්නකොට ගන්න inorganic chemistry. So inorganic මොන හරි තියෙනවද questions කරපු inorganic explain කරන ඒවා තියෙනවද කියලා අන්න එතනින් තමයි start මම දන්නේ. Because that how they have learned the lesson. They are asking the theory session. Right? They are asking the theory lesson of inorganic chemistry, not that gaseous state of matter. After inorganics, they will ask about energetics sometimes. Right? That's very important. So you are learning this lesson for very first time in your life. So I'm giving the foundation. Just get it better, right? Just believe this. Reactions of S-block elements. Reactions of S-block elements. So you know we have to separate, right? So then I'm separating like this. Like this. And again like this. And this is the species. And here group 1 elements. Group 1. Can you take group 1 elements now? Study it. Recently පාඩම් කරගන්න group 1 group 2. හරිනේ? Lithium, sodium, potassium, rubidium, cesium, calcium. ආසාවෙන් පාඩම් කරන්න පුළුවන්. Group 2. දැන් මටත් ඕලස් කාලේ බෑ මේකක්. එලස් එකයි මම ටිකක් පාඩම් කරා. elements පාඩම් කරලා මම කියනවා ආසයි තුන elements එක පාඩම් කරලා කියන්නේ. මෙහෙම කියනකොට මටත් ආසයි තුන එහෙම කියන්නේ. වැඩි කාලයක් ගියන ටක් ගාලා ගියා. elements තුන තමයි පාඩම් කරා. beryllium, magnesium, calcium. downwards group 2. beryllium, magnesium, calcium, strontium, barium, radium. ඉතින් එහෙම පාඩම් කරන්න ඒ level එකේ period table එක දෙන්නද දෙනවා. period table එක බල ඉන්නකොට බැරි. Yeah, I'm not sure period table එකක් දෙන්නේ නැහැ. At the end of the MCQ paper, they are giving one period table. So then always when you are turning it and coming to the question, you will be getting a good time. Right? So then group 1, lithium, sodium, potassium, rubidium, cesium, calcium. Group 2, please use colors when you are writing the note. Note colors use right? Anga black color available now. Otherwise I'll use right? Then try to use green, black, blue, red, all the colors when you're writing inorganic note. It's a colored note, right? Group 2. Beryllium, magnesium, calcium, strontium, barium, red. So I will show how we are analyzing, how we are making our note in our class. Now just see the note of an inorganic book, right? This is inorganic note. Right? This is how we are getting the inorganic note. Always we are making charts. Right? Can you see this one? It's compacted. Everything is available, right? Solubility, compacted, right? So likewise, in our sessions, I'm making some charts like this. Right? This P block, right? P block elements. And then we are discussing P block. So then I'll move to D block also. I want to show how we are studying them. Right? So this is entire P block. And then here is about D block. Right? See the D block elements. We are getting the start, right? And then we are moving to the upcoming cases. Yeah. This is nomenclature. Right? I see the smart nodes, right? And then these D block colors. Can you see using colors to? අදම මේවට ඔක්කොටම බය වෙන්න එපා right අසෙන්ට වීඩියෝස් පෙන්නලා හොඳට මේක ඉගෙන ගන්න පුළුවන් right colors ටික by heart කරන්න කියන්නේ නැහැ so these are colors right so then in D block we have to study element wise element to element right දැන් දෙකෙන් 2021 question එක අහලා තිබ්බේ complexes of manganese කෙලින්ම manganese ගැන අහලා තිබ්බේ manganese ගැන මේ වගේ study කරන්න right iron cobalt nickel copper zinc right? Then these are the summaries of those right? Within a summaries chart so then there's an issue with that note okay? So it's a key note right however right, I share it later that kind of a note is available so then please make your note also prepared note with the note let's discuss questions so then when your note is well arranged it will allow you to study these cases clearly that's a secret here right okay now the species and group so what is the first species we are considering the reactions of water how water will react with group 1 and group 2 elements is it there in resource book they have given group 1 first completely finishing okay. water acids hydrogen oxygen ඔක්කොම resource book එකේ group 1 එක ඉවර වෙලා තමයි group 2 එක දෙන්නේ resource book එක බලන්න but in my comparison I'm getting group 1 and group 2 together in one sheet and giving the reasons I mean giving the reaction with water how it changes what are the trends we have to study because in the question they won't ask group 1 question separately and group 2 question separately they will combine two elements and asking questions from this species right that's what we are making a note like this right water this is the very first trend you are learning in inorganic many inorganic wala palani trend එක so then I am advising you to get a A4 sheet like this okay get a A4 sheet like this and write inorganic trends in a separate A4 sheet A4 sheet එකේ දෙපැත්තේ ඔක්කොම trends ටික ලියන්න පුළුවන් there are like 30 trends if you are getting equations there are more than 80 equations in this lesson equations 80ක් විතර තියෙනවා but trends we can write so then I'll explain what are the trends right trends එක වෙනම ලියා ගන්න වෙනම කොලයක් අරගෙන ලියා ගන්න මම trend එකක් කියලා කිව්වා මේක ගෙදරදී නැත්නම් වෙනම මේ වගේ A4 sheet එකක් අරගෙන side එකෙන් ලියා ගන්න ගෙදරදී ඒක අපිට notice කරගන්න ඒක නිකන් law එකක් වගේ පාඩම් කරගන්නම ඕනේ දැන් Newton's law බලන්න අපි කියනවනේ හරි momentum change then we can so then we have to study that we can't change that so here also trends are like that you can also like theorems that kind of a thing okay group 1 elements reacts with water but it forms in this consideration of water when you consider water we have three states of water not ice okay, liquid and steam I mean when you consider reaction with water there are three conditions we are following number 1 cool water number 2 warm water or hot water number 3 steam what are the conditions cool water hot water and steam my first question which state is a bit difficult to react I mean if I'm reacting with steam if I'm reacting with hot water if I'm reacting with cool water which state is a bit difficult to react? If you consider a certain state with high energy, it is easy to react. If you consider a certain state with high energy, it is easy to react with that state than reacting with other states. Is it clear? Energy එකක් තියෙන state එකක් එක්ක react වෙන්න ලේසි. Then which state is a bit difficult to react? Definitely cool water. You think we are having a bath. Okay. So then if you consider hot water and cool water, which state is better to? It is more comfortable. Right? Either hot water shower එකක් එහෙම තියෙනවනේ. So then I mean it is more comfortable. Cool water නාන්න වැඩි hot water නාන්න එක ලේසි. Hot water කියන්නේ මේ 100 Celsius water වගේ නෙමෙයි. Right? Warm water. Clear? So then that's what I am saying. When a certain species is reacting with hot water and steam, it is easily reacting with those species because there's an energy, internal energy is available. But if a species is trying to react with cool water, that is kind of a destabilization. I mean, it is very difficult to react with cold water. Just an element is reacting with cold water, so it is highly reactive. It is highly reactive. Element එකක් cool water එක react වෙනවා නම් එයා හොඳ වැඩ කරනවා. කවුරු හරි හොඳ cool water ම නානවා නම් ice වතුර නානවා නම් ආයි කොහමද? hot water ඉන්නක් නැහැ. Right? Very simple. Yes, okay. Now what we have to say, group 1 elements, keep remember the trend, all elements will react with water. All elements will react with water and they will form what? Hydroxide plus H. Hydroxide plus H2. Hydroxide plus H2. What is hydroxide? You know that is OH minus. මෙන්න පළවෙනි trend. Trend number 1. So let's write an example. Now if you get sodium, the solid, reacting with all forms of water on a format, then how we mention cool water? Have we cool right? We just write H2O liquid. This is cool water. Cool water can cool කරපු වතුර නෙමෙයි. fridge එකේ දාලා දෙනේව නෙමෙයි. I mean if we get general water like this, it's cool water. මේකට cool water කියලා තමයි කියන්නේ. Water at room temperature is called cool water. So then sodium with cool water, what it forms? Then if it is hot water, how to write? Just mention hot here. The vanilla and H hot killian. Then how to mention steam? Vapor? How to mention vapor? We write steam here. No. What is that? Yes, the answer is correct. That is H2O gas. H2O gas. Is it there? That's how we change. Now I hand it right? Cool can H2O liquid tam. Hot nan, warm water nan, hot killian. Vapor nan, gas killian. Right? Okay. So this is H2O liquid. Then when sodium reacts with cool water, what it forms? When sodium reacts with cool water, it forms hydroxide plus H2. Then we can mention sodium hydroxide aqueous. Aqueous means well soluble in water. Soluble plus H2 gas. In inorganic chemistry, these physical states are not compulsory. But if you can put physical states, that's better. You can understand about the gas or the solid or the liquid. Right? And it's better to put it. But in the exam, they are not taking this into mark considerations, right? Exam එකේදී marks දෙනකොට inorganic වලට physical states mention කරන්න ඕනේ නැහැ. Sodium with cool water forms sodium hydroxide plus H. Tell me, rubidium. Rubidium with steam. So you know steam means H2O gas, but it forms. Rubidium with steam, it forms is what? Same thing. All group 1 elements reacts with all the forms of water and forms hydroxide plus H2. In monkey trends ටික පාඩම් කරගන්න. So if we know the trend, we can give any point. Right? We know the trend, we can give any point. The pattern is same, right? So rubidium with H2O gas will form rubidium hydroxide plus H2. Okay. So I want to ask you one question. how many equations we can write from this trend in group 1? If we assume lithium, sodium, potassium, rubidium, francium, these elements, how many elements we can write? So how many equations we can create from this? Number of equations, group 1. Yes, very good. Is it? Yes, what is the answer? Very good. Received many more answers. Figures they got 18 equations. These elements with cool water, 6. These elements with hot water. These elements with steam. Then we don't write all 18 equations. That is what practically we are studying this theory. All elements will react with all the forms of water, especially cold water, hot water, and steam, right? When forming hydroxide gas. Now, can you understand the difference between equations and trend? This is a trend, these are equations. So, do we want to study equations or trends? Do we have to by heart or do we have to keep remember the trends or the equations? Definitely the trends. ඕක දන්නෙත් නෑ සමහර අය. Equations පාඩම් කරන්න හදන්න. ඉවරයක් කරන්න බෑ. That's very important. Okay, now I'll be moving to the next part. Before moving to the next part, I have to say, when you move downwards the group, what will happen? The reactivity will it increase or decrease? Lithium part එකක් water වලට add කරා වගේ නෙමෙයි. When you are adding a part like CC, highly reactive. They will react very fast. You can't add a piece of cesium to water. You're adding U and B remaining. Let's see. We got a video. This is showing the reactivity. This is showing how these elements are reactive, right? React. So this is the first video I'm showing under S block to you. Let's get it. Right? Pretty interesting video. Give me 1 minute. Right now we can see this. Just watch it carefully, right? Right. Now we can see the video on your screen, right? Isn't it? It's like an animation. Right, okay. So that is kind of a visual, right? I don't know. So then what you imagine, right? Lithium, sodium, potassium, rubidium, cesium, calcium, how the reactivity is increased. You know, videos on YouTube, you know, just search alkaline elements with water. Alkaline elements with water. That's interesting. That's how we have to make this interesting. Otherwise, this is not interesting, right? I mean, by watching some videos, animations, by answering questions, writing reviews, studying with short notes will make everything clear. Yeah. Yes. Let's go to group 2. So in group 2, what is the trend? When you are moving group 1 to group 2, definitely the reactivity is getting decreased. Reactivity accordingly. Then even in group 2, when you move downwards to group, the reactivity will increase. When you move downwards to group, reactivity will increase. So how we have to say is think beryllium, magnesium, calcium, strontium, barium. Beryllium, magnesium, calcium, strontium, barium. But we have to understand simply cool water, hot water, and steam. Make it now we know when we consider element beryllium, the reactivity is very low. But magnesium, calcium, strontium, barium reactivity will increase. So what do you have to say? Beryllium, will it react with cold water? Will it react with cold water? Beryllium? No. Because reacting with cold water is very difficult. Cold water reacting with beryllium with cool water is bit difficult. So then this is your second trend. This is your third trend, and this is your fourth trend. Then in the first table you get 4 trends. The main trends මුළු inorganic ඔක්කොටම තියෙනවනේ නෑ. S block එකේ තමයි ගොඩක්ම තියෙන්නේ. S block එකේ තමයි තියෙන්නේ. P block වල එහෙම trends නෑ. S block ටික study කරන්නේ මේ trends ටික දැනගන්න. මොකක්ද inorganic S block එකේම ඉවර වෙනවා. හරි. එයා inorganic S block එකේම හරි ඉවර කරනවා අයින් කරනවා. එයයි මේ trends දන්නේ නැහැ නේ පුතා. මේ equations ලියද්දී ඒගොල්ලෝ බය වෙනවා. ඒකයි business book එකේ equations ගොඩක් තියෙනවා දැක්කම බය වෙනවා. එහෙම ඕනේ. trends එකයි. equations 18. අන්න එකයි secret. Beryllium, cool water, there's no reaction. Hot water, beryllium will react with hot water or not? No. මම කොහොමද දන්නේ? ඒ සමහර ළමයන් ඇයි එහෙම react වෙන්නේ නැහැ කිය? එහෙම හන්ද තමයි. We have reacted beryllium with hot water. We don't get any gas bubbles. That's what we see. We have to study the trend. Steam. Steam means H2O, water vapor. So then there's a high energy in steam. Then will beryllium react with steam? Yes, definitely react. React when or the circuit reacts. What are the products it will form? Only පාඩම් කරගන්න ඕනේ point. Beryllium reacts with steam to form oxide plus H2. Oxide plus H2. Then beryllium reacts with steam to form oxide plus H2. So let's write the equation for that. The equation beryllium solid reacts with steam H2O gas will form beryllium oxide plus H2. Let's move to magnesium. You know, magnesium is more reactive than beryllium, right? So then when you consider cool water, will it react with cool water? Magnesium. Cool water means, I mean general water. Magnesium doesn't react with cool water. But for the magnesium reacts with hot water. Again, magnesium කැලක් අපි මේ වතුරට දැම්මම ඒකත් එක්ක කිසිම gas bubble එකක් එන්නේ නැහැ. හරිද? But මේක warm කරනකොට Bunsen burner එකේ මේක warm කරනකොට අපිට පේනවා gas bubbles එක දෙකක් එන්නේ. මොනවද gas bubbles කියන්නේ? Hydrogen gas. That means magnesium reacts with warm water, not with cold water. Is it clear? So that is what you have to understand. Keep remember the trend. අමාරුවෙන් හරි trends ටික පාඩම්. පොඩ්ඩයි තියෙන්නේ. S block විතරයි. Right? So magnesium reacts with hot water to form what? Hydroxide plus H2. මේකමයි හදන්නේ. Right? Hydroxide plus H2. Plus H2. H2 කියන්නේ hydrogen gas එක, right? Magnesium, will it react with steam or not? So the cool water react when in hot water react when steam react when definitely react. If a certain species is reacting with cool water, definitely it will react with all the other forms. Cool water so when magnesium consideration, when we are considering magnesium with steam, it will react with all the forms of steam and it is forming again oxide plus H2. Right? Steam. We get reactions magnesium with hot water, H2O liquid hot reaction. Equations balance 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 inspection this balance. Right? The theory can focus on equation balance redox in the balance inspection method. Here and here. Right? Beryllium with H2O liquid forms magnesium hydroxide. Magnesium hydroxide is a precipitate plus H2 on a hot pot. Then magnesium with steam. So that's steam. So when you consider the reaction magnesium with steam, H2O gas, what it forms? Right? It forms oxide plus H2. Magnesium oxide plus H2. Keep remember that. Right? Okay, finally calcium strontium barium. When you consider calcium strontium barium reaction with water, what do you think? Now downwards group reactivity is increasing. So when you consider calcium strontium and barium, definitely they are getting the reactivity like group 1. Group 1 will transfer ability. They have the reactivity which is just equivalent to group 1 reactivity. So no need to think about any other case. Just think calcium, strontium, barium, and radium. Even after this, they will perform as group 1. What is the group 1 trend? All elements will react with water to form hydroxide plus H. All elements will react with water to form hydroxide plus H. That's the case, right? So then here, you should say all species will react with all the forms of water and forms hydroxide plus H. Right? Hydroxide plus H. Hydroxide plus H. That means calcium, when it reacts with steam, it doesn't produce oxide plus H2. So that means beryllium, magnesium, oxide plus H2. But calcium, strontium, barium, they are having the reactivity like group 1. So then when they are reacting with steam, even they are reacting with steam, they will produce group 1 species, hydroxide plus H2. Can you imagine? So then when we get what is the method? So when you get calcium solid with H2O liquid could be cool water. And then calcium solid with H2O gas. But it forms. Okay? Not oxide plus H2. It is having group 1 reactivity. We should say that is calcium hydroxide plus H2. Calcium hydroxide plus H2. Is it clear? That is very important to understand. When you consider calcium with H2O liquid and H2O gas, they are forming hydroxide plus H2. Hydroxide plus H2. Is it clear? Right. How many trends we have discussed? Number 1, all elements will form hydroxide plus H2 in group 1. Number 2, beryllium doesn't react. Beryllium just react only with steam, forming oxide plus H2. Number 3, magnesium reacts with hot water to form hydroxide plus H2, react with steam to form oxide plus H2. Number 4, calcium, strontium, barium will react with all the forms of water to form hydroxide plus H2. ඔන්න ඔය ටික මෙමරි එකේ තියෙනවා නම් මේක ගොඩ. නිසා මම කිව්ව ට්‍රෙන්ඩ්ස් ටික වෙනම කොලේ කරලා පාඩම් කරන්න. ඒ ටික තමයි ස්ප්ලිට් එක. ට්‍රෙන්ඩ්ස් ටික නැත්තම් හිර වෙයි. right? ඒක කියන්නම වෙන්නේ. ජෙනරලි දැකලා තියෙන විදිහට මේ 23 22 ස්ටුඩන්ට්ස් ලා ටිකක් මතක තියාගන්න ඇබිලිටි එක චුට්ටක් විතර සමහර අයගේ අඩුයි. මම දන්නේ නැහැ කියලා මොකද අර ඔන්ලයින් ඉගෙනගෙන එහෙමම ජෙනරේෂන් එක චුට්ටක් වෙනස්නේ. නිසා ඇත්තට බයි හાર્ට් කරගන්න සීන් එකේ නෑ ගොඩක්. නිසා චුට්ටක් එක්ස්ට්‍රා පොටෙන්ෂල් එකක් දෙන්න වෙයි මේ ටික. මගේ එක්ස්පීරියන්ස් එකේ විදිහට. ඕකේ. කතාව ඉවරයි. right? දැන් මෙතනින් පස්සේ තව ඒවා තියෙනවනේ. ඔව්. Reaction of S block elements with oxygen. Reaction of S block elements with nitrogen. reactions of S block elements with hydrogen, reactions of S block elements with acids. ඔන්න ඔහම තියෙන්නේ. මේක ලියලා තමයි ළඟේවට යන්නේ. ඉතින් මේකේ කොහොමද මම note එක දෙන්නේ? I'll share the note here. Give me 1 minute. So then S block elements reacts with water. We have many more videos. Right? I'll show another video in the next day's session. Just give me 1 minute. And note එක මේ වෙලාවෙම ලියන්න ඕන. මම board එකේ photo එක group එකට කොහමද දානවා. මම මේකේ අපේ note එක වෙනම තියෙනවානේ. Right, okay. So let's complete this. Right? My note එක මෙහෙම කරන්න. I'll share the note. First of all, I'll add a photo of this, and then you can start writing. First, start writing this note while I'm adding the photo. Right, this one. Use different colors. Use different colors. But there's a notification from our coordinator. So then our coordinator will talk you for a certain time. For the අපේ coordinator ඔයගොල්ලෝ පොඩි information එකක් notice එකක් දෙයි. ඔයගොල්ලන්ගේ paper class එකේ coordinator ශානි මේ miss වගේම මේ theory class එකේ coordinator ශානි miss එක්සත් චුට්ටක් කතා කරයි. ඒ නිසා note එක ලියන ගමන් පොඩ්ඩක් අහගන්න. Right? Okay. You can continue. And then this is the second part. So then I have added a photo of the previous chart in your WhatsApp group. So then you can take it from there, and then you can get a screenshot if you couldn't write it. Right. So then I'm going to finish within 5 minutes. Right. Just 5 minutes more. So then this is that part. Right. It's that part. And then when you consider the reaction between air, what we have to understand. Okay. Here, remember, when we consider group 1 elements, they are reacting with air. They are highly reactive. Air means generally we are considering oxygen. Okay, we have oxygen and nitrogen both, but here I'm considering oxygen. Just tell me, when elements are reacting with oxygen, what is the compound it forms? When a certain element reacts with oxygen, what it forms? When you are reacting with oxygen, the formed compound is oxide, right? Oxide, magnesium with oxygen, magnesium oxide, calcium with oxygen, calcium oxide, right? But here in group 1 elements, since they are highly reactive, if you remember, when you consider lithium, it reacts with oxygen to form oxide, right? Oxide. But when we consider sodium, it reacts with oxygen. Basically, it will form oxide. It will form oxide, but this oxide will furthermore react with oxygen. The oxide oxide is reactive. It will react with oxygen and it will form peroxide. Oxide එකට වැඩි reactivity එක වැඩි state එක තමයි peroxide කියන්නේ, that is called peroxide. But when you consider, that means in sodium we get oxide and peroxide. What is the major product? Most abundant product is peroxide. If we get oxide and peroxide mixture as 100%, peroxide is 70%, oxide is 30%, 70 to 30. Then what about potassium? You know, potassium is more reactive than sodium. Since potassium reacts with oxygen, but it forms. At the beginning, potassium will form potassium oxide. But potassium oxide will react with oxygen to form. Oxide will react with oxygen to form potassium peroxide. Peroxide, right? Then potassium peroxide reacts with oxygen furthermore. Potassium reactivity ki vara nahi. Even peroxide reacts with oxygen to form what? Superoxide. Superoxide. Can you understand? I mean, downwards a group, they will form more reactive species. Oxide to peroxide, peroxide to superoxide. So related to potassium, you have three products: potassium superoxide, potassium peroxide, and potassium oxide. Which one is most abundant? I mean, in higher proportion, we have superoxide. This is like 70%, 20%, 10%. 70%, 20%, 10%. What is the difference? Oxide means O2 minus. Can you remember what is peroxide? Peroxide means O2 2 minus. What is superoxide? It is O2 minus. Oxide, peroxide, superoxide. You understand? Oxide, peroxide, and superoxide. That is the variation. So then we have to write equations. So when lithium reacts with oxygen to form lithium oxide. What is the formula of lithium oxide? The equations මෙතනින් පස්සේ ලියන්න ඕනේ. Lithium reacts with oxygen to form lithium oxide. So lithium කියන්නේ Li plus. මතක කරගන්න. Oxygen means O2 minus. Exchange the valences. Right? So you get Li2O. සමහරට formula ලියන්න බෑ. Lithium oxide. Then sodium reacts with oxygen to form sodium oxide. Right? Give me 1 minute. Sodium reacts with oxygen to get sodium oxide. Right? Na2O. Then sodium oxide reacts with oxygen to form sodium peroxide. What is peroxide? How to write peroxide? Na plus with O2 2 minus. Then how to write the formula? Get this 2 here. Put this one there. So peroxide is Na2O2. This is sodium peroxide. Na2O2. Right? But when you consider potassium, potassium will give superoxide. Potassium will give superoxide. Superoxide. So superoxide කියන්නේ potassium, it is KO2. K plus O2 minus. That's the variation. Group 2 නම් කිසිම කරදරයක් නැහැ. All elements react with all the forms of oxygen and just form oxide. I mean, in group 2 elements, they will form peroxides and superoxides, but that is not relevant to the syllabus. Right? So we say all elements reacts with oxygen to form oxide. Basically the oxide. If you get barium, it will form barium peroxide. Right? Barium superoxide. But not available in the syllabus. Generally, we have to study all elements reacts with oxygen to form oxide. Right? That's all. So then how many trends I have explained here? Alin trends 4යි. Then this is the 5th trend. Lithium with oxygen forms only the oxide. 6th trend. Sodium with oxygen forms oxide and peroxide. Most abundant product is peroxide. Then potassium with oxygen will form oxide, peroxide, superoxide, everything. Abundant product, highest proportional product is superoxide. So 6th one, 7th one. And this is 8th one. Under group 2, all elements react with oxygen to form oxide. Is it clear? Right. So then you have understood that part really well. So then I'll discuss only one MCQ question and finish the session here. You can write the note at home, right? I'll add the photo to your WhatsApp group. So this is the question. Please do the question well. It's an MCQ. Select the answer, right? 1 minute. Give me 1 minute. Right. This is the question, right? Agatha, you can see the question in your screen. I'm asking the answer for 2014, question number 28. 2014, question number 28. Right. So we need your answers. So you have identified, you have understood the lesson really well. Then try to get your answer. And add an image of this, right? Definitely I'll add an image. Can remember the sequence? Principal products obtained when lithium, sodium, potassium, magnesium react with excess oxygen at atmospheric pressure. Yes, yes, very simple. Now you have to study the theory. Lithium, it forms what? Sodium, potassium. Right. Then when you consider group 2 elements, what it forms, right? So then just focus on that. Oxide means O2 minus. Peroxide means O2 2 minus. Superoxide means O2 minus. O2 minus means superoxide. O2 minus. That is superoxide. Okay, so what is the answer? No, questions inorganic. We should know the trend and we have to get the answers from the trend. Okay, so what is the answer? Right, is it 1, 2, or 5? Yes, so I'm going to reveal the answer. Please send your answer. Someone answer I'm confident now, right? So keep remember here, from lithium you get lithium oxide, right? So I can explain lithium oxide. So then how to write lithium oxide? Li plus, then oxide formula O2 minus. So now lithium oxide. But from sodium, you know the major product is sodium peroxide. So the sodium is N plus. Peroxide means not O2 minus nevi. O2 2 minus. This is exchange current, right? May 2 එක මෙතනට එනවා මේ 1 එක මෙතනට යනවා. ඔන්න sodium peroxide. අංකවල ඉතින් potassium වල තවත් එහාට යනවා. reactivity එක වැඩි වෙන නිසා potassium ගේ major product එක තමයි potassium superoxide. Superoxide කියලා කියන්නේ O2 minus. ඔන්න බලන්න. හරි. So then what is the answer? Group 2 මම කියවනේ ඔක්කොම oxides විතරයි හදන්නේ. එවන් answers මම මේවා. හරි. දැන් හැමෝම හොඳට අහගෙන හිටියා. ඔයාලටම answers එවන්න පුළුවන්. right? Is it answer 2, 4? කොහොම එකම answer එකක් එවන්න ඕනේ දැන්. හරි. Yes, 2, 4, or 5. හොඳට බලන්න. Yes, Kavisha, yes, Tisani, Tirani, Vagisha, Dineti, right? Ravini, I think you have given the correct answer. Bhavya, Dahamya, right? Then what should be the correct answer? Yes, Shweta, Halya, Tashmi. Yes, I'm going to finish this here. It's answer number 2. Lithium oxide, sodium peroxide, potassium superoxide, and magnesium. Those are the products. So then answer is 2. Now we can understand the sequence here. Right? We can understand the issues here. So then that's how inorganic behaves. So in the next week session, I will discuss more questions and I will be adding a spot test related to inorganic. Don't miss it. Try to do it, and we'll discuss it in the theory class. In the paper class, we'll be discussing a paper from chemical questions part. Okay. Then see you in the next time. I'll be adding a photo of this. So then, stay safe. Good night.